Okay, class, let's continue with our lecture. Um, number 11, doing number 11, 12, 13. So we have a piecewise function here, number 11, and our negative 3 is bound to x happens to be greater than or equal to, x has to be less than or equal to 0, and then our 2 minus x has to be bounded to where x happens to be greater than or equal to 2. Okay, so I'm going to choose the first one here. So it's going to start from 0. Okay, so again, if you look at this as a linear equation and it's in the slope intercept form. Okay, now we have a slope here of negative 3 over 1. So when you do when you actually draw your graph, it's just going to look something like this. Okay, now this is going to be negative 3x. Okay, now if you want to draw the other graph, 2 minus x, as it adheres to this condition here where x has to be greater than or equal to 2, we're going to start from 2 here. This is 2 right here. And then we can just draw a line going down that way. And this is going to be 2 minus x. Okay. So now when we perform our horizontal test, as you can see, I have a line going, is only intersecting at one location here. I have another horizontal line intersects this location here. But when I draw a line here, as you can see, intersects this point and intersects this point. So this question right here, number 11, is no. No one-to-one. Because it crosses 2 points along this particular piecewise function. Okay? Let's do number 12. So number 12, you can look at number 12 and you can see that if I draw a horizontal line, it crosses 2 points along this graph here. If I draw another horizontal line, it crosses this point and this point. So number 12 is no. Okay. Number 13, if I actually create a horizontal line, it only crosses this point. It crosses this point right here. And if I draw another horizontal line, it only crosses the graph only at one point. So this is a one-to-one. Okay. Now let's go on to the next page. Go to number 14. Again, you look at number 14. If I draw my horizontal line, only crosses this graph only at one point. I draw another horizontal line, only crosses the graph at one point. So this would be yes, one-to-one. Okay, number 15. As you can see, if I draw a horizontal line, it crosses the piecewise function at two locations, right here and right here. So therefore, this is no. Number 16, I have a piecewise function. Again, it doesn't cross, when the horizontal line only crosses one location on this graph, another location on this graph. Now when we get here, as you can see, this is open. When it's open, that point is not really considered on the graph, right? And then, but it crosses this closed point right here. That point is considered to be on the graph. So in this case, it's going to be yes, a one-to-one. Okay. Now number 17, of course, this is going to be a one-to-one function. Okay. Yes, it's going to be a one-to-one. Okay. So let's move on. let's look at number 18. So number 18, we're asked to use the composition cancellation equation to verify that f and g are inverse functions. Okay, so I'm going to take, let me come up here, use a thinner marker. This is number 18. Okay, where our f of x equals 3 over 2x minus 4, and our g of x equals 2x plus 8 over 3. So our solution, we know that whenever we see, when dealing with composition, you could denote a composition like this, equals our f of g of x. Okay, that's what that typically means. So now, wherever I see my x, this function right here, I put in g of x, as you can see. Okay, so whenever I'm looking at my f of x function, wherever I see an x, I'm going to plug in this g of x into that x. Okay, so let me just clean this up a little bit. So what happens now is we're going to get 3 over 2, which is this right here. And now this x, I'm going to bring this 2x plus 8 divided by 3 into there. It's going to be 2x plus 8 divided by 3, right? Then I'm minus 4. Okay? So when I take that a step further, I'm going to get 6x plus 24 divided by 6 minus 4. If I take that a step further, I'm going to get, and my 6 can actually cancel out. 6 could go into 6 one time. 6 also goes into here 4 times. So I'm going to be left with x plus 4 minus 4 equals x. Okay. Now I'm going to do the exact opposite, where I'm going to say now g of x equals g of f of x. Okay. And I'm going to do the same thing. Okay. And in doing so, what I'm going to get now is this g of x, this g of f of x, I'm sorry. All I'm saying is this g into 3 over 2 x minus 4. Because this is f of x right here, right? This whole thing right here is f of x. Right here. Is right there. Okay? So when I do that, I'm just going to, wherever I see in my g of x, wherever I see x, I'm going to put in 3 over 2 x minus 4. That's all I'm doing. Okay? And when I do that, I'm going to get 2 into 3 over 2 x minus 4 plus 8. I'm going to divide that by 3. I could do the math. When I do the math, I'm going to get 6 over 2x minus 8 plus 8 divided by 3 equals 3x over 3 equals x. Okay? So by these two, let me use a different color here. By these two here being equal, okay, equal to x, okay, F and G are composite functions. Well, F and G are inverse functions. Okay. All right. So this is X, which was here. This also was X. When you do the math, you got a X. That was for this composition. Okay. So by them equal each other gives you the indication that they are inverse to one another. Okay. Um, number